Hello everyone, I'm back with a new project, a little bit different than what you are used to with on my channel, but is another hobby of mine. And this particular project is, I can even say, an invention because I haven't seen it anywhere else. Um, Everyone will see it here for the first time. And let's get straight into the subject. The basic idea of this project is that it will detect, and it will prevent possible hazards on the motorways, on the roads, and if other cars are trying to prevent you in crashing into different objects like vehicles in front or I don't know, pedestrians, wildlife, or objects in the road. This system is actually helping you in through stopping the other ones behind you in crashing into your car. Yeah, let's see a short. Obviously, this is just let's say a prototype, um, not at a full scale. Initially, this was the cheapest radio control car that I was able to buy from the market at this size. And the reason why I wanted that this big, so I can accommodate inside all the system's components. So looking from outside, we can see that we have in front two sensors. One is a ultrasonic sensor, and the other one is a microwave, a radar sensor. We have headlamps, headlights, really bright. You will see that shortly. And if we'll go here, we have a main switch on this side, and on the back we have I will turn it on so I can. Yep. We have a 7-segment 4 digits, and that is reading the distance in front. Now that I've moved it a little bit backwards, we can see that we have 29 centimeters. The distance is shown in centimeters. It's a simple algorithm to calculate that from the sensor, so nothing complicated. Also, we can see that we have position lights, brake lights, these three. So on each side we have 3 LEDs that are for the brake, and the bottom one is for the position. Also above the LCD we have another brake lights bar. So basically I can turn the lights on. You can see they are very bright, and also the side lights are coming on, and we have brakes as well. Good. Having said that, I will pause the video so I can open the vehicle and see what we have inside. Alright, so now with the vehicle open, I will give you a quick view about all the components. So at the base, at the heart of this project is a PIC32 microprocessor with a development board. Very expensive, honestly. I don't know why I choose this option, but I did it. I could have easily go with an I don't know, an Arduino, or even to program this one in C++ is more complicated than with other development boards. But it's done, dusted. Now I'm going to show it to you. So this cable here is for the for connecting to your laptop PC. and connect the debugger. Yeah, so on the front here, that this is a input output multiplier, and here we have a few sensors at the normal, in any, let's say, normal vehicles, road vehicles. This system is like this, continuously reading the front sensors, reading the distance from the objects in front, then in the same time is reading a sensor on the brake paddle to detect when the driver is braking. Also, we have a motion sensor detecting the speed, an accelerometer detecting the speed of the vehicle, and pretty much that's it. So the algorithm behind is very simple. When an object is detected, the distance is calculated immediately, and is also calculating the braking distance in for the speed of the vehicle. And if that distance is very close or even smaller than the brake distance, and also the driver presses the brake pedal, the lights in that moment, the brake lights will not just turn on solid, will start flashing. The reason why I choose that, and I see it as a huge improvement, is that usually on the motorways, on busy roads, generally, sometimes the drivers are not paying attention to the traffic ahead, especially when there are queues. And here in UK we have many queues, many blocked solid roads during the rush hour, and it's enough one driver to have a quick look on the side, or on the dashboard or something, and the corner side, human corner side, can't detect when it goes from side lights to brake lights. Is just one change that doesn't always get perceived by the corner side, when it is well known that the corner side is much more receptive to quick changes. So then I thought, okay, we are going to change the way the brake lights are coming on. They will start flashing, and that will for sure indicate to the drivers behind you that you are going to stop the car, there is an emergency, and they will react with the same importance. Probably like me as well, not once you've been in the position driving behind of a lorry, a van, a big SUV, or a car that you can't see through, you can't see the traffic ahead, and you don't know why the driver in front of you is braking. He wants to stop, he wants to slow down, we don't know that, and then we don't react with the correct importance. So the idea behind this, if you can see that the brake lights of the driver ahead, they start flashing, you will know for sure he is stopping the car, he needs to stop, and you will press the brake pad with the right force, pressure, and you will stop, and you have just a fraction of a second till when you are thinking, how should I brake? Slow brake or harsh brake? And that fraction of a second sometimes can cost you not necessarily the life, but at least your front part of the car. Yeah. So because I was playing, coming back to my prototype, because I was playing with this car, I've also added a few features like the front lights. I can control those from my remote. Oh, my remote, 3D printed, incorporated 2 transceivers, and in the car we have 2 receivers. The reason why, as I was saying, with these radio control vehicles, cars, you don't have a brake. So I had to think of a way how will I let know my processor, my microprocessor, that the driver is pressing the brake pad. There is no brake pads in this car. The car doesn't brake through normal, let's say, friction between the brake pads and the discs of the wheel. So in this case, what I did with the second receiver, which is there, I used one of the channels, and when I press the red button on one of the channels, a signal goes into one of my sensors. If you'll bear with me one moment, I'll tell you exactly which one is. In this moment, can't remember exactly all. One of these 2 sensors. So, excuse me, the signal from the second receiver goes into one of these sensors. It's just a simple transistor gate, and then a 5-volt will go into one of the inputs, and this is how the microprocessor will know if that input is high. Then will know the driver press the brake paddle. And another thing that I had to overcome, let's say, with this kind of vehicles, there is no braking distance, because literally the braking is done by cutting the power to the motor, and then the vehicle will stop. So what I did, I created another micro sensor that will detect the voltage on the motor, and when that voltage is high, when there is a voltage different than 0, then the input on the microprocessor will be high as well. So the microprocessor will know that the vehicle is moving. When that voltage is 0, there will be a 0 level on the digital input. So another information for the microprocessor. What else is to be shown here? Oh yeah, so as I was saying, on the back 7-segment display, we have the distance. This is a simple momentary latch switch. When I press once the button on the remote, it will turn on the lights, and we'll keep them like this. We have also a small relay, and when I press another time on the button, it turns off the lights. Nothing complicated. This system, this project is not about the construction, the hardware. To be honest, I think all the cars that are produced today, and in the last, let's say, maybe 5-7 years, maybe 10 years, they are all hardware ready to implement this system. All they need is a small software update. And also, for the older cars that don't have this entire, let's say, hardware, already from the manufacturer to implement a system like this, and it can be made much more simple than I made it here. To implement this kind of system will be probably just 1 or 2 hours in a service, and the technician will make the changes really quickly. Yeah, my strong belief about this system is that will help and will reduce the number of small accidents on the roads, small accidents that are causing mayhem on the roads, and definitely will reduce the number of the vehicles stranded in traffic, the fuel consumption wasted on those tens of minutes while the cars are stranded will save our environment. Let's see how it works, if it works. Of course it works. So in this moment, as we can see, we have a distance of 106 centimeters. I know that ultrasonic sensor is not very accurate, especially above 100 centimeters, but it will serve the purpose for this demonstration. And if I'll press the brake button, I'll try to show you. And if I can, no, I can't. So if I'll press the red button, then we have solid lights, because in the code I set the limit to be, if I'm not totally wrong, 50 centimeters. Anything under 50 centimeters will trigger the brake lights to start flashing. So if I'll move a little bit closer, I have some objects in front. The distance is 57. Let's check. Yeah, I think it's 50 centimeters. I don't remember all the details of the code. It's a very long code. As I said, programming this microprocessor wasn't quite easy, and maybe just for me. I'm not an expert, but I'm still engaging programming tasks. And it wasn't quite the best choice that I made for this. Let's see, 47. All right, so we can see now that the lights, because they are detecting the objects in front, the lights are flashing when I'm pressing the button. Sorry for shaking the camera that badly. Let's try to put, oh yeah, this is. So the lights are flashing. If I'll move backward a little bit, solid again. The distance is about. I'm pretty sure that we are all able to spot this changing. Obviously the frequency of the lights turning on and off can be adjusted, but I'm pretty sure we are all able to see this quick change of the lights, brake lights, with our corner sight, even if we are watching, I don't know. You know very well when you are stuck on a road, especially in the rush hour, you are getting bored and start looking on the other side of the road, or in the dashboard changing the radio channel, whatever we are doing, anything else but looking at the traffic ahead, and that fraction of second could make a huge difference. Yeah, basically this is my project, my idea. Let's call it automation, automotive innovation. I wish to see this one being implemented in vehicles, and definitely it will help you being crushed by the other ones behind you. I don't know what else could be said about this idea. I will leave it here. It's already like 20 minutes. So thank you for watching this. Hope you like it. Please post your comments, and see you at the next project. Ta-ra!